All right, here we have number 4. All right, a cylindrical barrel with a diameter of 2 feet, so radius 1 foot, contains collected rainwater as shown in the figure above. The water drains out through a valve not shown at the bottom of the barrel. The rate of change of the height of the barrel with respect to time is dH dt equals negative 1/10 square root of h, where h is measured in feet and t is measured in seconds. And then it gives you the formula for volume of a cylinder. Find the rate of change of the volume of water in the barrel with respect to time when the height of the water is 4 feet. Indicate units of measure. Alright, so we're looking at volume here. And volume is pi r squared h. These are both constants in this equation, in this situation, anyways. Normally, pi is always a constant. R would normally be a variable, but in this case, r is equal to 1. We're going to take the derivative first before bothering with that. But, so, to find dv dt, we take the derivative of this. Since these are constants, we're just going to have pi r squared. This is the thing that's not a constant. It's not volume, or it's not time. So it's just going to be dH dt. Well, like chain rule, right? It'll be the derivative of h, which is 1, times the derivative of h, which is dH dt. And furthermore, we were told that dH dt is negative 1/10 square root of h. So this is our derivative with respect to time, listed in forms that we can actually do something with, because we're told to find the rate of change of the volume when the height is 4. So dv dt when h equals 4 is pi. The radius is 1, so 1 squared, negative 1/10 square root of 4. This ends up being 2 over 10 is 1 over 5, so we're at negative pi over 5. B. When the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. Alright, so just looking at our derivative here, we'll do the intuitive one first, which is not useful, but we'll do it first. Essentially what's happening, right? So as something drains, as h is getting closer to 0, the rate of change is going to go down, right? Like, you have something full of water, you have that water cooler, whatever, and as it drains, it doesn't pour as quickly because there's less water pushing it out the bottom. And that's more or less what's going on here. It may or may not actually be square root form, but it's draining slower as it gets emptier. Now, the intuitive answer is that it's going to be increasing. Now, this is because it's negative. Right, it's negative 1/10. And so, our rate is getting closer to 0. It started negative, and if it's getting closer to 0, it's increasing. That's the kind of intuitive answer. The answer we're actually looking for is going to be the algebraic one. There we're looking for essentially the second derivative, right? We want to see if this is increasing or decreasing. To do that, you take the derivative and see if it's positive or negative. So, let's do that. Alright, so B. We have dH dt equals negative 1/10 h to the 1/2. Because we're going to take the derivative here, so I might as well turn that into that. Alright, so our second derivative, d squared h over dt squared will be negative 1/10 Okay, so 1/2 times h to the negative 1/2. Times, since this isn't t, we need to also multiply it by dh dt. Right, we have another implicit differentiation going on here. So yeah, times dh dt. All right, so this ends up being negative 1/20. We'll just put the square root of h down there, times what we had to begin with, which was negative 1/10 square root of h. This ends up being 1/200. Just straight up, right? Our square root of h's, we have one on the top and the bottom. So we just end up with 1/200. This is a positive number, so our derivative is increasing, so the rate of change is increasing. So increasing, I'm off the screen here, sorry. Increasing, because 1/200 is greater than 0. Alright, let's look at C. At time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. Okay. So we're given dh dt equals negative 1/10 square root of h. And we're given when t equals 0, h equals 5. Okay. So this will give us our constant, essentially. So separation of variables, get dt over here, get h over there. So we have 1 over the square root of h, dh equals negative 1/10 dt. And alright, so this is h to the negative 1/2 dh equals negative 1/10 dt. Okay, so we anti-differentiate. We're going to add 1 and divide by our new one, so that's 2 h to the 1/2 equals negative 1/10 t plus our constant. Now we've anti-differentiated, and we can plug in this stuff to give us our value of c. Alright, so h equals 5, so we got 2 square root of 5 equals 0 c. So 2 square root of 5 is c. Does it ask us to find this in terms of t? Yes, it does. Okay, so we have 2 square root of h equals negative 1/10 t plus 2 square roots of 5. We want to find this in terms of t, so solve for h, essentially. Alright, divide by 2 and square everything. Cool. Square root of h is negative 1/20 t plus square root of 5. Square everything. H is negative 1/20 t plus square root of 5 squared. And that's, I mean, you could distribute and do all that stuff, but this is fine. Yeah.